Look up at the night sky. What do you see? Stars, galaxies, our Milky Way. But how did our solar system come to be? Today, on Exploring the Universe, we journey billions of years back to witness its incredible birth. It's more dramatic and awe-inspiring than you can imagine. Our story begins not with a bang, but with a vast, cold, diffuse cloud of gas and dust, a giant molecular cloud. These colossal stellar nurseries are the raw ingredients for stars and planets, primarily hydrogen and helium. Imagine a cosmic fog, incredibly thin, yet full of monumental potential. For eons, this cloud drifted. Then, subtle density fluctuations, perhaps from a supernova shockwave, triggered gravitational collapse. Even the weakest gravitational pull began to draw material inward. As more material accumulated, gravity strengthened, accelerating the collapse, a runaway cosmic snowball effect. As regions contracted, something fascinating happened. Due to the conservation of angular momentum, the collapsing cloud began to rotate. As it spun faster, the material flattened into a rotating protoplanetary disk, or proplide. Think of it like cosmic pizza dough. At the center, where most mass gathered, temperatures and pressures skyrocketed. This dense, hot core was our nascent sun, a protostar. For millions of years, the protostar accreted mass, growing hotter and denser. Powerful magnetic fields ejected material in jets from its poles. Eventually, the core reached 15 million degrees Celsius. At this unimaginable heat and pressure, hydrogen atoms began to fuse into helium, releasing immense energy. This was the moment of stellar ignition. Our sun, a true star, was born. This magnificent event marked the beginning of our star's long, stable life. With the sun now shining brightly, the remaining material in the protoplanetary disk had its own destiny. In this swirling dust bowl, microscopic dust grains began to collide and stick together, a process called accretion. Electrostatic forces helped these minute particles adhere. Over time, these tiny clumps grew into pebble-sized grains, then small rocks, and eventually kilometer-sized objects called planetesimals. With planetesimals ranging from meters to hundreds of kilometers, the process became more violent. Gravity took center stage. These growing bodies exerted significant pulls, leading to frequent, energetic collisions. Some shattered, others merged, growing larger. This chaotic period of bombardment and accretion eventually formed larger protoplanets. Conditions in the disk weren't uniform. Closer to the sun, temperatures were scorching. Volatile materials like water couldn't condense. This left only high melting point materials, silicates, and metals to form solid planetesimals. This is why our inner solar system has terrestrial, rocky planets: Mercury, Venus, Earth, and Mars. They are small and dense, formed from elements that withstood the sun's heat. Further out, beyond the frost line, it was cold enough for ice to condense. This provided much more solid material, not just rock and metal, but vast quantities of various ices. With abundant raw material, outer solar system protoplanets grew enormous. Their immense gravity rapidly accreted vast envelopes of hydrogen and helium gas from the nebula. This is how the gas giants, Jupiter, Saturn, Uranus, and Neptune, were born. They are colossal, with small rocky cores surrounded by thick atmospheres. After millions of years of chaotic collisions and gravitational sculpting, the major planets settled into stable orbits. Not all leftover planetesimals were incorporated. Between Mars and Jupiter, Jupiter's strong gravity prevented planetesimals from forming a planet, leaving the asteroid belt. Beyond Neptune, the Kuiper belt formed, a vast reservoir of icy bodies. Even further lies the theoretical Oort cloud, a spherical shell of icy comets, the outermost reaches of our solar system. And so, from a vast, unremarkable cloud, through a cosmic ballet of gravity, accretion, and fusion, our magnificent solar system emerged. It's a testament to the powerful, transformative forces of the universe. Every atom in your body, every star you gaze at, is part of this incredible cosmic story. We are stardust, born from ancient supernovas, nurtured in a protoplanetary disk, standing on a planet that is itself a product of this grand saga. The formation of our solar system is just one incredible chapter in the endless cosmic epic. If you're as fascinated by the universe as we are, and want to continue exploring space and time with us, then make sure to subscribe to Exploring the Universe. Hit that like button if you found this journey through cosmic history mind-blowing, and share this video with anyone who loves to ponder the wonders of our universe. Your support helps us continue bringing these incredible stories to life. Until next time, keep looking up